Polynomial graphs is the name of this module. So first of all, what is a polynomial? A polynomial, trying to think of a non-mathematical definition here for you, but it has, let's say, whole number exponents. I think that's probably the easy way to define what a polynomial is. Again, this is like I'm trying to not do a super mathy definition here. So whole numbers, remember, are 0, 1, 2, 3. So it is got to be positive. It's got to be, so you can put positive number exponents, but I guess whole numbers shouldn't be good because, no, you couldn't have fractions. Okay. So on this one, like, you just look at this and you say, okay, this has an exponent of 9 and 4. This one has an exponent of 2 and 1. Do you remember what you could rewrite the square root of as an exponent? Have we talked about that? I don't remember. So the square root of x is the same thing as x to the 1/2. Because what that says is, like, the square root of 36 is saying what number 2 times itself is 36. Well, 36 to the 1/2 is saying what number, this number down here says what number 2 times itself is 36. Okay, of course we know the answer is 6. But the square root of x, exponent, is actually 1/2. So since this is 1/2, this would be no, it's not an exponent. It's got to be a whole number that's positive. This one that just has a number, this is actually like y equals 7, so it's a horizontal line, so it would be a polynomial. The harder way to think about this, or the math way to think about this, is that there is an x to the 0 power at the end of this. Do y'all remember what x to the 0 power is? 1. Okay. So x to the 0 power is 1, so that is why you can have x to the 0 at the end of a number like that. And then this one, to drop it down there, this is actually irrational, but to drop it down, it would have a negative exponent. So you are looking for ones with a positive exponent. I guess that may be easier to say for my definition. You want positive or 0, it could be 0. X minus 4, x minus 3. Where's my, there it is. Okay, on this one, it says find the zeros. So what find the zeros means is when it's all set equal to 0. So you set it equal to 0. This is the same thing as finding the x-intercepts because you are setting y equal to 0. Okay, so this is the same thing as finding the x-intercepts, or just setting the whole thing equal to 0. So on this one, you would do 4x equals 0, x minus 4 squared equals 0, x minus 3 squared equals 0. And I'll kind of work this one out the long way. And I don't know how much, we do go in this to the next topic, so I won't talk too much about it. So to solve each of these, we divide by 4, so it's x equals 0. 0 divided by 4 is 0. On this one, you could write it out as x minus 4 times x minus 4 equals 0. And then separate both of those equal to 0. Now, I'll show you a shortcut on the next problem. So you add 4 to both sides, and you get x equals 4. This one is the same thing, so you just get x equals 4. On this one, same idea here. You could set both of those since there's 2 of them equal to 0, add 3 to both sides and get x equals 3. So my zeros are 3, 4, and 0. Okay. So when they say find the zeros, you just set it equal to 0. It's just a different way of saying that. You're saying what makes the function equal 0. So find the zeros, you set it equal to 0. All right. Now the next topic, I'll kind of show you how to shortcut that topic just a little bit. Minus 13 minus 5 plus 8. No, I don't remember anything I said. 9 minus 13 minus 5 plus 8. Okay, so this is you're gonna do the same idea. This one right here does not have an x in front, so you don't have to set that equal to 0, okay? That's just a number. So what I'm gonna do is I'm actually just going to set whatever's on the inside equal to 0. And I'm kind of ignoring the... I don't need you to solve it, Apple. I'm ignoring the squared and the cubed right now for just a second. I'll talk about that in just a second. So solving each of these, I add 13, I add 5, and I subtract 8. All right, so those are my zeros. What they have is they have multiplicity. The multiplicity is how many times you get that 0. So if I go back up here for just a second, when we did this, we had the same equation. So we actually got 4 twice. When we did this one, when I separated out, we got 3 2 times. The reason you got it 2 times is because it's squared. So your multiplicity has to do with the exponent. So my multiplicity on this one right here would be 2. My multiplicity on this one would be 3. And my multiplicity on this one would be 2. Okay. The multiplicity tells us different things about the graph. Sorry, I went blank there for just a second. How much do they talk about the multiplicity? I didn't want to go too deep if I don't have to. So the multiplicity tells us different things about the graph. Our goal on these problems is kind of like the idea of why you take math classes. You have a big puzzle. Like if I told you to graph this right here, there's no way that you could just look at it and just graph it, right? But if we start looking at these little pieces, then we could figure out where to graph it. So the rule here actually, and I don't think you have a topic on this, but I feel like it's something we should go over. If I were trying to graph this, I have x equals 13, 5, negative 8. Okay, so these are my x-intercepts. What the multiplicity tells me, now I got to remember, if it's even, it touches the x-axis and turns around. I don't think I'm getting these backwards. If it's odd, it crosses the x-axis. Okay? So what this tells me is at 13, drawing the graph this is kind of hard without doing one thing first. Y'all already know this though. If the numbers out in front is positive, will this graph, like, think parabola, will open up or down? Up, right? So this graph is going to be like increasing as it goes. So what it means is it's going to start down here and finish up here. Okay, it's going to be increasing. It's going to go up from left to right. So that's called the end behavior. I think we'll do that in a second. But that is, you can tell that by the front number. Okay, so now I can look at this. So if I'm at negative 8 has a multiplicity of 2, which is even. So I know that it's going to come and it's going to hit this and it's going to turn around like this, okay? And then at 5, it's odd, so it's going to cross this one like this, somewhere like this. And I'm just kind of giving a ballpark of idea of what it's going to do. At 13, the multiplicity is even, so it's going to touch it and turn around, okay? So now I have these pieces of the graph that I can start to get an idea of what the graph is going to look like. So if I just had to guess of what this is going to look like, it's going to look something like this, right? This graph is going to, I can start to piece it together. So like that's the whole idea of you having to take a math class, is that no, you're not going to ever use zeros multiplicity in real life, most of you. Some of you might, but you get a big problem, you don't know how to solve it. Well, if I know how to do this piece and this piece and this piece, then maybe I can get enough pieces to get an idea of how to do it. So it's that critical thinking skill. So I don't think you have to know this, but this is like why we do it, because it does start to piece together the graph. All right, finding x and y intercepts of a polynomial function. I told you when we did x and y intercepts way back when, no matter how far you go in graph, you always find the x intercepts the same way. So, is that the one we want to do? Let me skim through and see what they got here. Let's do that one. Negative 2x cubed minus 8x squared plus 10x. What was it? Minus 8x squared plus 10x. Okay, so to find the x-intercepts, you make y be 0. So if I set this equal to 0, always check for the GCF first. So my GCF here, I could divide everything by negative 2x, right? Negative 2x. So that gives me x squared plus 4x plus 5. Now let's try to factor it, and it should be a lot easier. What multiplies to be 5 and adds up to be 4? Oh, that would be, I'm sorry, this should be a negative 5 right here, right? Because 10 divided by negative 2 should be negative 5. So what multiplies to be negative 5 and adds up to be positive 4 would be positive 5 and negative 1. So x times x is x squared. 5 times negative 1 is negative 5. 5 minus 1 is positive 4. So now I got to set them all equal to 0. Don't forget to set if you have an x out in front, you got to set that equal to 0 as well. Oh man, I didn't mean to change those. Okay, so divide by negative 2 and x is 0. Subtract 5. X is negative 5. Add 1. X is 1. So again, now I have 3 points on the graph of my x-intercepts. To find the y-intercept is always easier. To find the y-intercept, you make x be 0. So all you have to do is plug in a 0 for my x's. And that's just 0, isn't it? So now you have your y-intercepts. I have 3 y-intercepts. I got 0, 0, negative 5, 0, 1, 0. And on this one, I got 0, 0 as an x-intercept. So now I've got 3 points, because 0, 0 is on both of them, that I can graph on there. So along with, then we can look at this right here. If we wanted to, we could look at this right here and get the multiplicity of these. And we can, this is negative, so we know it's like going down as it goes from left to right. I think we talk about that in the next topic, so I won't go too much into that. But we can start to piece all these things together. Oops, I didn't mean to paste. All right, determining the end behavior of a graph. Oh, so this one we gotta kind of like look through. Okay. So the way this works, and I'll go ahead and write this out over here, but the end behavior, I've kind of already mentioned it. The number out in front, okay? So they use A for that. If A is positive, I always think like it increases from left to right, okay? What that means is it's going to start low and finish high, because it's increasing as it goes from left to right. Does that kind of make sense in everybody's head that as I look at it from left to right, it's going up? What they say is it falls to the left and rises to the right, I believe is the way that they word it. So as it goes to the left, it's going down. As it goes to the right, it is rising up. Okay, so that is if A is positive. If A is negative, less than 0, and A is just the number out in front, I think about it as it decreases from left to right. Everything we look at left to right because that's the order we read from. So this would start high and finish low, and that would create some kind of decrease from left to right. So this would be, the way they say it is it rises to the left and falls to the right. So it's rising as it goes to the left and it's falling as it goes to the right. So it's the opposite. All right. So go do this topic. The A is the number out in front, so here it is like -1. So you see the negative out in front. So the end behavior would have the downward track, so it's going to start high and finish low. So it's going to rise to the left and fall to the right. Oh, I knew I forgot something there. I knew it wasn't just quite that easy. Sorry, we got to backtrack for just a second. This is do y'all remember the degree? Somewhat? The highest exponent. This is when the degree is odd. You do it this way. If the degree is even, then it's always the same. If A is greater than 0, it's positive. So it would, it's always the same. So if it's positive, it would open up, rise to the left and rise to the right. This one's easy, so I just forgot about it. But think about parabolas, okay? If I think about parabolas, they open up, so they both go up, right? The left side and the right side both goes up. If A is negative, again, it's the same. I guess this one's the same. They both rise. And this is the same, both fall. So this would be, fall to the left, fall to the right. So this would be like a parabola opening down. Okay. I forget that because y'all know how to do the parabolas. Y'all answered that question real quick when I asked it a minute ago, but it is, if it's even, it's easier. Okay, so that's the first thing we got to check. The way you tell if this is even or not, let's see if I can. Oh, you do have to do the crosses and touches too. We'll work it out, and then we'll come back and work on Alex. Okay. So the way you tell the degree on this is that one only has 1. So you just do 1 plus 2. Oh, well, let me write. 1 plus 2 is 5. So that's my degree. Okay. So my degree is odd. So you know it's going to be opposite. It is A is negative. So we know degree is odd. A is less than 0 or negative. It's just a different way of saying negative. So you know it's going to look like this. It's going to fall to the left. I'm sorry. Did I put the wrong one in there too? I did. That should be rises to the left, falls to the right, right? Because try this again real quick here. Okay. Rises to the left, falls to the right would create that negative shape, right? Okay. So now we're on the same page there. All right, so 0 is where the graph crosses the x-axis. So the first thing we got to do is find our zeros. To find our zeros, we do x minus 2 equals 0, so x is 2. To find x plus 1 equals 0, that would be x equals negative 1. And to find x minus 1 equals 0, that would be x equals positive 1. My multiplicity for this one is just 1 because there's just an exponent of 1. My multiplicity for this one is 2 because there's an exponent of 2. My multiplicity for this one is 2 because the exponent is 2. Okay, so this is going to be cross, and this is going to be touch, and this is going to be touch because it's even is touch, even equal touch, odd equals cross. So where the graph crosses the x-axis, the zeros would be 2. The graph where it touches would be negative 1 and 1. To find the y-intercept, we're running out of room here. To find the y-intercept, you make x be 0. Which is usually fairly easy to do. 0 minus 1 squared. Okay, so this would be negative 2 with a negative out front. 1 squared would be 1. Negative 1 squared would be 1. So that would be positive 2. So my y-intercept is at 0, 2. Okay, so let's graph some points. So we got 0, 2 for my y-intercept. My x-intercepts are at 2, 1, and negative 1. And we know that it... I wonder if Alex lets us do this easier. We know that it starts high and finishes low. And then at negative 1, it's going to touch and turn around. So it's going to do something like this. Oh, that's there. What's this one? 1, it's going to touch and turn around. Okay. And then at 2, it's going to cross. So it's going to do something like this. Okay, that's kind of crazy looking, but that's our best guess of what it could look like. One of the other things that you can do on this is the number of turns, I believe, is always the degree minus 1. So if I did 5 minus 1, it should have 4 turns in it. 1, 2, 3, 4. It has 4 turns in it. It changes directions 4 times. So that's another thing that could be helpful on this. Let's see. Alex may make it easier on us. So let's graph these real quick. We had 2, negative 1, 1. Am I not saving it? 2, 1. Oh, I got to select it. It was... turns around at this one. So you can kind of see how Alex does it here. When I click the x-intercept, it tells me what the behavior is. At positive 1, it turns around as well. And you got to tell which way it's turning around. Does it turn around on up or down? No. And then at 2, it crossed. So it's going to look like that. Okay, I kind of like the way it does that. And then when you click this button, it will just graph it for you. Okay, so you'll have to think about which way it's going there. Just like I did, how I kind of started my graph. I didn't save that. How I kind of start my graph with the different ways. To do that, we can do another one because I feel like this one is the hardest one because you got to do it by hand. Let's do another one real quick. All right, so the first thing you want to do is find the degree. The degree here is 1 plus 2 plus 1. So my degree is 4. Okay. That tells us this is step 2 right here is we're going to do the end behavior. Actually, I'd go ahead and say based on the degree, my number of turns is 4 minus 1. I feel like that helps you figure out the number of turns there. Okay. So the next thing is the end behavior. If it is even, it's going to be the same. Degree is even. And my front number is positive. Okay. So that means it's going to be up. They're both going to be up. So it's going to rise to left and rises to right. It's going to do both. The x-axis are the zeros. We got to find the zeros. So step number 3 is zeros. So x plus 2 equals 0. X is negative 2. X plus 1 equals 0. X is negative 1. X minus 1 equals 0. X equals 1. So my multiplicity of this one would be a plus 2 that has an exponent of 1. The multiplicity of this one, plus 1, has an exponent of 2. And this one has an exponent of 1. So if the rule, again, is if it's odd, it crosses. And if it's even, it touches. So the x-axis, or where the graph crosses the x-axis crosses, would be negative 2 and positive 1, because those are the ones that have odd multiplicity. And then the next one would be 2, because that's the one that has even, where it touches. And then my last step here would be the y-intercept. So that is where you make x be 0. So what is that? 2 times 1 times negative 1. So that would be negative 2. All right, so graph my y-intercept. That's the easy one. Now when I graph my before I graph my x-intercepts, I want to think about, okay, I said they're both going to open up. So it's going to start high on the left and end high on the right. So when I go here to negative 2, it's going to make me choose. It crosses at the x-axis here, okay? So it starts high, so from left to right, it should be going down. And then at 1 is next. It also crosses here. If it crosses, I'm down here, right? So I know it's got to come down like this somehow. So it's going to cross this way. So we'll just draw this right here like that for now so you can see it. And then at 2, it's going to touch and turn around, right? That's where it turns around. So it's going to look like this. Okay. So that is what you would choose here. And then you would click the button on Alex and it should make your graph for you. Whatever, it's going to look something like that. And then you can look at the number of turns. It changes directions 1, 2, 3 times. Kind of a way to check it. Now, I know that's a lot of rules and different things. We will wait and see when we review on the test if one of these is on the test. If it is, then maybe we'll make a little cheat sheet that you can have on the test, because I wouldn't expect you to remember all of that. That was this one. Wait, was that the end behavior one? We haven't done. Oh, we got 2 left? I thought we only had 2 left. Oh, okay. Sorry, I accidentally. Okay. I thought we had 2 left and we got 3 left. All right, this one. This one, they give you the graph, and you're going to just look at it and go through those different things that we talked about. So let's see what they have here. Which of the function is increasing? Which of the intervals is increasing? So remember, it's increasing from left to right. You use your x values. So from -8 to -5, it is increasing. All right, it's going up right here. It's also increasing from -1 to 3. And then it's also increasing right here from 7 to 9. At which x values does the function have a local minima? At which x values does it have a local minimum? So this would be 1, 2, 3. So at x, those are at -8, -1, and 7. What is the sign of the function's leading coefficient? Okay, so we are starting high and finishing low. So I would say it is going to be negative because it does have a downwards track to it. It is decreasing as it goes from left to right as a whole. It's okay that you have up and downs in the middle, but as a whole, it's going down. Which of the following is a possibility of the degree of the function? Okay, so since these are opposite, we know the degree is odd. What else do we know? We could look at the number of turns. So the number of turns would be 1, 2, 3, 4, 5, 6. It changes direction 6 times. So it's definitely 7. I'm scared it could be 9 also. But I'm pretty sure it's 7. Let's solve it real quick. Yes, it can be 9. So that's hard to get into with the number of turns there. That's a different thought process. This one can be 9 because the number of 10s, that's like doesn't always work. Like it just most of the time works like that with the different can be degree. All right, here degree can be 9 as well. Let's see if they have a better explanation for that than I do. Okay, it has at most, with the number of turns, it is at most 1 less than n. So 7 minus 1 would be 6, but 9 minus 1 would be 8, so it could have up to 8 turns. This one only has 6. It's not going to have more turns than that n minus 1. So that's the way that I would do it in my head, and I kind of hesitated about that, and I knew it was right, but I would say there's 6 turns, so I know my degree has to be odd, so it has to be 7, and then it could be anything higher than that as well. Any other odd higher than that. Okay. That's the easy way to think about that. All right, the last 2 topics are the easy ones, or should be, hopefully. I honestly have not worked these, so I have no idea. I may even have to look at the explanation here to do this. This one is a full-on graphing calculator that you have here. That is what we just did, was doing it by hand, but we have technology to do most of this stuff. So this is putting it in the calculator and doing it. It has been a long time since I've done this, and I don't know if I've ever done it on the Alex calculator, to be 100% honest. So let's just see. Maybe I should go ahead and look at the explanation and have it open just to have it. It should be super easy to do, but I don't want to have to do it a hard way on accident. So I click, sorry, I'll walk through my steps here. The first thing I did was click y equals. The y equals sends you to like how to put a graph in. So 3, I click this button right here too to make it turn on. You can change the color of it if you want to and different things like that, but we don't really need to do that. Bold and dotted, see? But that turns the ones on that you want to see. So 3x to to the fourth. Sorry, this calculator has stuff in different spots that I'm not used to as well. Three x to the fourth minus x cubed minus 5, oh no, minus 5x squared. Sorry, I probably should get out my keyboard for this and not do it on my iPad. Plus 2x minus 1. All right, so you put that graph in there. You go to graph, and it graphs it for you. That's obviously a lot easier than doing all that work we were just doing, right? All right, so what are we trying to find here? We are trying to find the local extrema on these. So you can, like, click trace and actually go to those spots. The problem is it's really, really hard to get exactly there. Most of the time, Alex is going to look at those. And no, they do not. We have decimal numbers. Okay, so it's very, very hard to tell when you're at the bottom when you're tracing it, right? So they have this extrema button. This extrema button allows you to kind of give lower bounds and upper bounds of where it is. So you can move these. I'm going to go ahead and just type it in because it'd be easier. So I want to find it. You know, the one on the left is between -2 and 0. Okay. So if I click find extrema right there, that finds the one I am looking for. So you can make it go between the blue lines, or you could just type this in. So -2 and 0, you got to identify where they are by looking at it. Then you click find extrema, and it says my x is -0.89 and y is -4.15. So that's the first one. So now if I clear this, now if I want to go do the other one, the one on the right looks like it's between like 0 and... So you got to kind of identify a general area of where it is, and then it will find it for you. So 0 and 2. Is that right? -0.95 and -2.03. Okay. So everybody kind of see that. You click extrema, and then you got to tell it kind of where to look. Okay. I'm looking, like I know my local minimum is right here and right here, so I got to look. I got to tell the graph to look between like -2 and 0, and then tell it to look between 0 and 2 to find the lowest point in that area. Okay, so you kind of give it an area, and you find the lowest one to work there. The other one is finding the zeros. I'll put my keyboard on here so see if I can type it easier. So again, go to y equals, make sure you turn that graph on. It won't show up if you don't turn it on. Much faster. All right, so click graph. That makes the graph for me. To find the zeros, there is a 0 button right here. Again, I have to give it a location of where the 0 is that I'm looking for. I do not think it'll just do like the whole thing. Like if I just do -5. I don't know. Like if I just do -5 and 5, I'll put -5. Why doesn't it want me to put the -5? Well, it found one of them. Okay. So what you want to do is that you want to identify where a 0 might be. So like there's one, like see this 0 right here. -2, it's between like -2 and -1. So I go to -2 and -1. And I say find the 0 between -2 and -1. Okay, so that's -1.44. Okay. And then I go to my next 0, clear. My next 0 is like right here. So that's between like -1 and 0. Okay, so that's -0.39. Okay, so do y'all kind of see it kind of works the same way where you got to tell it kind of where to look generally, And then you can do that. So my next 0 would be like right here between, what, 1 and 2? 1 and 2. So I click find 0 and it'll find that one, 1.68. That make sense? So this is, I mean, I know the calculator's a little bit of a pain or whatever. But yeah.